Hello guys, the project is about basic neural network from scratch. You can see the presentation of this project in another video. Project is the simple handwritten digit classifier that I built from scratch using Python and NumPy. I made it as a learning project to understand how a neural network works internally instead of using the ready-made deep learning libraries. The main focus of this project is to practice the full flow step by step for propagation, loss calculation, backpropagation, parameter updates, and evaluation. Let me brief about this project. This project is built with Python and NumPy. This uses the digits dataset from the scikit-learn and a classification digits from 0 to 9. In this, we have trained a neural network with one hidden layer and also saved the loss and accuracy graphs from training, and there is a sample prediction image in the plots folder. Scikit-learn is a machine learning library but used only for loading the dataset. Neural network itself is implemented manually. So here is the project structure. Project structure in this, there is a ReADME file, then we have the plots folder in which there will be saved loss curve and the accuracy curve and the sample predictions after the execution of the training. This is the requirements file in which we have just the requirements of the NumPy, matplotlib and the scikit-learn. There is nothing more requirements for this project, and this is the sample digit, that is the digit. And now we are going to run the program. First, give me understanding of this project. This is the main.py, this is the module.py, and this is the utilities.py. So in the main.py, this is the main file of the project in which the main function runs. And when the main function runs, it loads the data, and the dataset is loaded from the utilities.py, and in this we have imported the dataset from the sklearn, and then we prepare the dataset here. We have split the dataset into the train and test x and y, and we have one hop encoding for this to change this into the required number of the scales. After the loading of the dataset, it shows and prints the dataset. In the input size, we have provided it like the 64-bit input size, the hidden size is 32, neurons and the output size is 10. Learning rate is 0.1, activation function is ReLU here, random CPU is 42. After that, going through the structure of the hidden layer, and then in output it gives the probabilities. Maximum probability becomes the prediction, and that prediction we compute the loss, and then after computing the loss we optimize that using the gradient descent function, and then using the Softmax function we updates the weights and goes the backward to the hidden layer and to the input. So let's run the function. Clear the terminal, run the function. So project is running. It is loading the data set from the scikit-learn library. It is the first sample, that is the flattened array of the 64 features. First label is the 8. Sample image, we have saved it into the sample digits here. This is the sample digit. Now let's go to the tree. We have used 200 epochs. It means there is 200 iteration. So training sample is 1438 samples are here for the training, and we have a test samples of 359. So in starting we can see the accuracy is just about 32%, 3%. After that, as well as the epochs, as the iteration increasing, their accuracy is also increasing and the loss is decreasing. So in this 200 iteration, the accuracy reaches to the 91.3%. So test accuracy becomes 93.04%. This is the sample predictions. This also saved in the file here. These are the sample predictions. Here we can clearly see that the predicted value is 2, then true value is also 2. Some are here like predicted value is 1, but the true value is 9. It is 12 samples in which there are 3 is wrongly predicted, but many are predicted correctly. This is the loss curve. We can see the training loss is decreasing over the e-pulses number increasing, and the accuracy is increasing as the e-pulses number is increasing. So in this way we have implemented the neural network from scratch. For understanding of the file, we can come to this. In this file, the utilities imported the calculate accuracy function. There is the project directories function, then load and prepare dataset, plot training history, and save prediction function. These are all the helper functions. From model, we have implemented neural network. This is the logic here built. Class is built in here. So in this we have initialized the class and the object made here is initialized. It checks the activation function. If the first layer scale, if the function is ReLU, then we use this type of the calculation, and if the function is sigmoid, we use second layer scale here. These are the functions mentioned here. These are not the inbuilt function. In the calculation we need the ReLU, and in the backpropagation for updating of the weights we need the ReLU derivatives. So we have made the calculation for that also. Here we have 3 types of the activation functions used in ReLU, sigmoid, and the Softmax. Softmax is the output activation function. ReLU and sigmoid are the input activation function of the hidden layer, that is the hidden activation function. So we have a hidden activation function and then we have hidden activation derivative function, because for updating of the weights we need the derivatives of the activations. In the forward propagation there will be input initialized with the weights and the bias, so it becomes the Z1, that is the pre-activation value, and this pre-activation value goes to the activation function, that is the given by ReLU function. And after this we have many of the functions. These all are really called in this when the model dot train runs. In the backward, when the backward function runs, there will be the updation of the backward function. So these all are in the main.py. Here we can see there is a plot training history in which the saving of the all type of output made here. That's all about this. Thank you.